Well, hi, welcome to my shop. Here we go on this radio. After checking it out, here's what I found. First of all, this is a hot chassis type radio. It has no power transformer in it, and this one, the chassis gets hot when you switch it off. It has it has a polarized plug. You have no choice which way you plug it into the outlet. And so we're going to look into that. But more curious than that, two more curious things. One, it doesn't work. It's not receiving anything. And of course we're going to go after trying to sort that out. And the other one is, with the set switched off, the tubes are lit a little bit. Now this is a curious thing. I'm guessing it's a leaky capacitor on the power supply, a line capacitor. But I'm just guessing. I hadn't even sat down and thought it through. I'm just guessing at that. Another idea that's come from Joeseph is that there might be a diode installed across the switch. So when you turn the set off, power continues to flow into the set through the diode. But it's so restricted that it just keeps things kind of half working a little bit. So the heaters are a little warm. It's the old instant on trick for televisions. Back in the 70s, when instant on became the big thing. Instant on really was never quite off. That's really what it was. And you just use a simple diode to do it. So we might find that in here. So I'm pretty curious about why the set is half on. Frankly, never encountered it before. So I'm pretty curious about that. So let's get it out of its cabinet here. And oh boy, right. I'm trying to pull out off a knob that actually is locked on with a screw. That's not a good idea. Now, these knobs. Now the way they've done these ones is they're solid plastic, because to support a screw and the pressure that's put on that screw, you need either a metal ring in here. Three things. You need a metal ring in here that can take the strain, a large body like this that can take the strain, or just make sure you don't over tighten the screw and put too much stress in here, because over time this will crack. Now this guy's held on because this is so big. Let's see what the rest of them look like. The liller knob here worries me a little bit, but I suppose if it hasn't cracked now, it's not going to crack, and it looks to be in pretty good shape. Same thing again, solid body on this. I think that's why this radio still has its knobs. Yeah, they're all in perfect shape. Uh-oh. Can't get at that screw. It's underneath there. Come on. There we go. Okay, let's look underneath here. Now the radio is unplugged. Anytime this radio is plugged in, I will have my hot chassis warning light connected on a counter. As I work along here, I will do things and really not be thinking 100%, and I could very well leave this radio in a state where the chassis is hot right on my bench right in front of me. Now, just for interest's sake, one of the ways I keep myself safe here is, well, I'll show you. Yeah. Yes, I'm wearing rubber-soled slippers. Okay, it's just as good as running shoes, really. Number one. Number two, I sit on a chair which is on plastic rollers, which is up off the floor. My floor is bare cement, which isn't the best thing. It's painted cement, but that's not going to help much. If I was in here in my sock feet, I'd be taking my chances, that's for sure. So there's a number of things I'm doing all the time to keep myself safe, and believe me, it only takes one moment of forgetfulness. And let's see, the last time I got a good shock in here, I was holding my one of my cameras, and which I thought was a plastic shelled thing. As it turns out, it's got an exposed metal print on it. Believe it or not, metal print. I got to show this to you. This is my my other camera. The word Microsoft right there is actually metallic and is grounded into here, which is grounded all the way back through my my computer. And I would never have thought that. I was holding it like this, and I was just sure I was holding a plastic shell. In fact, this is probably aluminum. It's no plastic in it. And yeah, so you never know. You just never know what it is that's going to ground you, literally. So no matter all the precautions you can take, there is a risk in doing this. Okay, so let's see. We're gonna pop this plug out of here. I think, you know, one of the rules I know from working in a power company, one of the safety rules was the line person in Ontario, Canada anyway, and probably in most of the world the rules are the same. The line person has the right to go wherever he has to go to see that the switch that controls the circuit he's on is open, and to actually be able to see that the switch blades have separated. They have a legal right to do that. And I don't know how often a lineman would exercise that right. Half the time they're the ones opening the switch, so they've seen the blades open. Now, you know, they can open the wrong switch. I mean, there's all kinds of ways to make mistakes. Don't we know that? But interesting enough, they have that right. Well, what that tells you is that it's very important to have a complete separation, and in order to make it impossible for whatever you're working on to become energized. And the way I do that in the shop here is I unplug things. Even though the power to the plug that I use is controlled by some switches just over here to my left, and they're off, I still unplug this. But when this is unplugged, there's really no chance at all that this should become live. So, and I can see it with my eyeballs. It's not a switch, which in the case of a power system, the switch could fail. They're large mechanical devices, and literally the blades come loose and don't move and stuff like that happens. And you can operate the handle, but the switch blades remain in place. It can happen. And then some poor lineman's going to be told, go ahead and start your work, and the next thing you know, he'll be in big trouble. So that's the reason for these rules. Okay, let's pull this out. Let's pull that out. Whoops, I left one screw in. I left one screw in to make it extra challenging. Ooh, this guy's got 2 original feet, and he's got 2 fakes up here. And these aren't as big as these rubber ones. The radio's on a bit of an angle. It's hanging on that screw a little bit. There we go. Okay, I find something good and solid to grab. That's the chassis itself. Out you come. Whenever I do this, I'm always feeling if there's anything tugging back at all, anything at all. That string, this particular string, that's not going to happen on this radio, but on some radios, you start pulling the cabinet out and the string that controls the pointer is all connected up in stuff that's not going to come out. And the next thing you know, no strings attached. That's not a particularly good thing. in a radio. Yes, and I have some really horrible stringing videos of me suffering terribly as I try to fix a string on it's a big German radio, which I've done a few of those. Yikes. Okay, so let's just take a look on the back here and see what we can see. Why is this so loose? Oh, okay. That's not too hard to figure out. Let's take a look here. Okay, why is this loose? Because there's a bracket right under here. And there's a screw, and the screw is essentially inaccessible. See that? It's behind the plate. So it's been put on with a screw that's come loose and nobody can get at it to tighten it. Yeah, it's not interesting. Okay, that's why that's loose. It's not going to fall out or anything. But you know the consequences of that? I noticed them a little bit ago. Sorry about all the shaky camera work there. The consequences of that. Right in here, there's now a crack in this black backing. Hard to see. If I move this around, there's a crack here, and a crack here, and a crack here. And that's from this eye pushing forward on the plastic just a little bit. Just putting in a little bit of stress, and the material's no good in tension, and it's cracked. So luckily, if we fix that, flatten this out a little bit, those cracks are essentially invisible. Because this is a major feature of the radio, is the front of it, especially this radio. It's a major feature. And if it gets ruined, the whole radio is kind of terribly devalued because of that. So I see we can bend these tabs. Oh, this one is bent, broken off. So we can bend these tabs and pull this out and get at the inside a bit. But we don't want to bend these tabs too many times. So someone's bent the lower tabs, broke this one, probably dropped the glass out, leaving these tabs the way they are because they barely look. This one looks a little bit like it's been bent. And then they've gotten at this plate here. Why? I don't know. I see some of this foam has come loose here. Maybe it had come away over. I don't know. The other thing is the pointer might interfere with the backing up here. Let's just check that. Let's see. Sure enough. Look at that. Okay, so that's not good either. That's going to cause problems in here. Didn't this radio make funny sounds when we got up in this area? Just as we were crossing here, the whole tone of it changed, as if something was shorting out. And I figure it's the capacitor in the back, but you know, who's to say at this point? Curious that this arm hangs up on the back at the same point where that problem occurs. Okay, well, let's see if we can figure out what's going on with the on-off part of this thing. The on and not quite off. Can I turn this one right upside down? No. I have to do a lot to get this one to stand right upside down. Wow, isn't that good? Hasn't that got a little bit of dust and gunk in it? Well, it's got a number of new capacitors. A power supply capacitor. These capacitors are new. There's one down in there. Well, some interesting looking parts in here I've never really seen before. Let's see. It's resting right on a tube, so let me fix that first. Okay, that's a little better. Well, now. Well, there's lots of paper capacitors in here. Some new resistors. A fair bit of work's been done, especially up in the upper part of the radio. Up in here. But there's lots of original parts in there too. Now, what's the action with the on-off switch? I'm going to vacuum this out first because I can't see anything in there. Okay, so be a little loud. Okay. Well, I say, well, there's quite a few replaced parts in here. Let's take another closer look at it. Okay, so we'll start right down the bottom, just working our way up. See what all we can spot. Old parts back in there, and this is another layered radio. Oh man, look at them in there. Right on. Yeah. And you're seeing it on your screen expanded. I mean, you're getting a good close-up here. In real life, I can hardly figure out what all's in there. Oh man, look at it. Stuff chucked in there. There's some very interesting parts I've never seen before. There's one, that orange, green, brown thing, which, I'm pretty sure that's a resistor, but I've never seen anything like it. It's kind of a square guy. Yeah, there's a bunch of those in here. Never seen them before. Here's another one over here. Right across that old capacitor there. Now, there's a lot of monkey business in here too. Look at these. These two resistors. That's interesting. It's put in with one of these. Now these are a relatively modern thing. Tie wraps. And it's a very old resistor here. So if someone's tie wrapped in a very old resistor, I'm sure those are pretty old. The two of them in series, they've been joined together here. Okay, you can see the capacitor in here. One here. Oh, lots of parts have been changed. Hey, I think that's a diode. I think that's a diode right across the switch. So, Joseph, I think you were right. It looks like somebody's turned this into an instant on by sticking a diode across the switch. And as I said before, with the set turned off, that leaks a small amount of current into the set. Who needs this to be instant on? I mean, who would need this thing to be instant on? So I think that's an unfortunate move myself. I think it's a foolish move also to do that. So we're going to remove that. There's no advantage to keeping this thing warm for months and months and months, and then turn it on for demo purposes if that's how it's being used. Certainly in the past, this was a heavily used radio. There's no doubt about it. Here's an old ground connection going nowhere. New capacitor here. Nice new power cap here. Here, now what about this guy? He's still in the circuit here, I think. Yeah. It would look that way. So what have they done here? They've connected this capacitor in parallel with the older one here. I think I would tend to remove something like this. It's going to give you a lot of space on the radio to do more part work. What's that? That looks like another diode here. Diode going into a resistor. What the heck is that? Looks like a diode, maybe it isn't. So somebody clever has worked on this, and then there's that capacitor. I thought it only had one lead on it because I just for the life of me couldn't see the other lead, but it's definitely in there. It's almost grounding out on the chassis too. Now where's the high wattage resistor? There it is. Right, there's one there anyway. But you know, who knows if somebody worked on this, if they weren't using high wattage resistors where they weren't needed, and then I can come along later and kind of get fooled by it. This looks like a cathode resistor and a bypass capacitor right across it. That's what this looks like. And the same thing here. Well, this tube, this connects to a tube that's the output tube. This makes sense as a cathode resistor. Not so much this one. It's a low. It's 270. This is a 270 ohm resistor here. Don't know what that's about, but no doubt it's been added by whoever worked in here before. Here's the power cord coming in. How did he manage to make that solder joint up in there? These parts right on top of it. Somehow he did. And what's going on with this capacitor? This capacitor, which I'm sure was added in newer. Let me get the focus here. Sorry about the camera work, but I can't watch the screen 100%, and well, maybe I can watch the screen 100%. Let's try that. So this is kind of weird because this capacitor appears to be connected in series with this one, unless no, there's another wire. It looks like it's just shooting down to ground. So this is just a ground point here. That's all that is. Oh my. Lots of old parts in here. Lots of old parts. That one's particularly old too. How old is this radio? The parts in it look older than the radio. I think. This radio must be pretty old. Especially with that declaration on the back about the radio is only going to be used for experimental ham reception and broadcast band, which I guess is the other way of saying I'm not going to use this radio for spying purposes. I guess that's what that was about. So this might be a wartime radio. Maybe this is early 40s and the war was on. And, well, I'm not seeing anything else. So how are we going to approach this? I think, you know, offhand, I don't know that any of these parts are bad. I don't know anything about any of them. And we'll get rid of that diode on the on-off switch right away. And geez, I don't know. I guess we can bring it up on my high voltage DC power supply, and we'll bring up the DC power on the set and look at the leakage. And we could check to see that the DC is making it through the set here and there. And do all that without actually turning it on again. Of course, we've had it on for a while. That didn't seem to cause any problems. No smoke came out of it. No funny sounds. So we could use the internal power supply if we wanted. So I mean, the first thing we'll do, we'll bring it up on the external power supply. We'll hook it up to the capacitor here, charge up the radio's high voltage circuits, look for any leakage current of substantial leakage current. If there was, I think we would have discovered that when we had the set running, because something bad would have happened. But we'll do that first anyway. It's a pretty safe thing to do. And then after that we can switch it back on and we can check for B plus at the key tubes, at all the tubes really. And we'll probably find something missing. Something doesn't get its B plus. And at that point we can hunt down an open circuit somewhere. That's my theory. My theory will probably hold for about 10 seconds. That's kind of how this work always goes. But you know what? If I don't have a theory, I haven't got too much of an idea what to do. You know, then just fall back on standard stuff. Wow, that's a big capacitor there. That's a great big. That's the biggest capacitor of that sort I've ever seen. Oh, the thrills and spills of radio repair. So let's get the DC power going here. Now I've made lots of improvements to my video operation here in my shop slash TV studio. And hopefully you're seeing the benefits now of everything I've done. I think I've resolved everything: sound, video, quality, 2 cameras, a whole shot, and more. There's more stuff coming that I haven't done yet, that you haven't seen. But I think I'm at a stable point now where the world is great. And so I'm just looking for a good place to hook up the DC supply. So I see that the negative terminal on this big power supply filter capacitor is connected to a pin which is then bolted right to the chassis. So that's a clear indication that this chassis is really tied in with the radio circuitry in that respect. And you know what? These metal knobs, they were protruding through the front of the radio when I took the knobs off. So this is a fairly dangerous radio in that sense. Until we get the situation with the hot chassis resolved. Oh, speaking of which, I should always have my hot chassis light clipped on it at all times, so I'm less likely to forget to have it on there. Not that it can be hot now; it's not plugged in. So I think I could just go right on here. I can go right on the chassis. Why don't I do that? Put my clip lead in a better spot. And then this guy is going to go right on the positive terminal of the filter capacitor. I'm not going to worry about the diode and the switch. I don't think it matters for this at all. The on-off and all that stuff is very isolated electrically from where I am now. All looks good. Let me get another camera shot ready here. One of the things I'm going to try to do with my video productions here is do longer segments, 20-minute, half-hour segments of one long shot like I'm doing now, in order to reduce the edit time, because every moment I spend working on the video is a moment not working on the radio, and really that's not really what I'm trying to do here. I'm trying to work on radios, not... Now, just give me a moment here while I get this other shot set up. So, hang on one second here. Whoa! Whoa! Tried to raise my tripod there and I actually came apart in 2 pieces. I think that'll do the trick though. I think this will do the trick. So I just want you to be able to see the voltmeter on my power supply. And now my camera's trying to focus and refocus again. There we go, it's steady. Okay, so just checking again now. Is everything ready? We have connected. Now this is a very safe test. I mean, I can't blow anything, I don't think, as long as I do this with a little bit of caution. Okay, so we'll take a look at hey, you know what? I'm gonna try something a little. No, we're gonna take a look. Never mind. Ignore me. Getting ideas and then rejecting them right away. So there's my power supply. So current flow, voltage. This is a 400 volts, and this guy, the red line is at 100 milliamps. So it'll put out a pretty good chunk of power here at high voltage. So we're all set to go. I'll switch it on to there, and you keep your eye on the current meter first. But we shouldn't expect anything bad because the set was operating. So we'll take it up. If you just heard 3 little beeps, because I can hear it, and I think if I can hear it, you can hear it. That was my coffee pot signaling that it was shutting off its heater. Nothing to do with this. So see, as I turn the voltage up slightly, you can see a charge. You can see on the current meter a charge flow in. You can imagine it flowing into the capacitor and charging it up. 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 Not a bad sign at all. But it is fast. And that's a pretty big capacitor, I think they got stuck on there. So we're up in the 200 volt range. We'll put it right on 200 here. 200, virtually zero leakage current. And that's just what we kind of want to see. So we'll leave that running. Now, keep it firmly in my mind that there's a large DC voltage on this radio. Okay, and what we're going to do now is we're going to figure out better lighting here. It's this guy that's causing that problem. Little by little, I'm learning all the tricks here. I have to learn better. My focus now won't be, in terms of videos, won't be so much on the technology and getting the recordings efficient and all that kind of stuff. Now it's all about how to produce nice videos for you to watch. And hopefully I'll figure a lot of good stuff out. Okay, so let's look for that DC voltage, which we think is 200. It might be a little over 200. Of course, the best place to look for it is right on the terminal here. Okay, so it's actually 184. It's not over 200. That's good. So let's just check a few tubes. Let's go on the output tube, and we'll just poke around and see what we see. At some point, we should see pretty much this entire voltage. There it is, 183. So we know that's getting through to the output tube. A B plus on this tube here, which is probably an audio amplifier. I don't know. Might not be. Well, did I just do them all and got nothing? Still there? Yeah. So here's a tube. It looks like it's got no high voltage going to it. I missed a pin right here. Very carefully, you know, when I get something anomalous like this, I have a lot of doubts, as I should, that I've done it right. Yeah, well, that would certainly explain a lot, wouldn't it? Am I injecting the DC in the right point? I don't think it can be wrong. Once you charge up, once you attach to one of these big filter capacitors, the DC is going to, I hate to use the word penetrate, but penetrate the whole radio from there. Oh, why do you hate to use the word penetrate? Because electricity doesn't penetrate anything. Not really. Okay, so that tube is, he's out of luck for DC. That's a great hint on what's going on. Now let's go and look at the next tube. Oh my gosh, buried. Well, here's one that's not buried. Let's check this one. Well, there's the voltage right there, right away. So, there it is again. That's probably screen and plate. That's ground. And is there another tube hidden under all of this stuff? Yikes. Oh, son of a gun, there's a tube under there. Oh boy. There's a terminal. Oh boy. That's incredible. I'm just feeling around in the dark here. I don't like doing... Oh! There it is. Okay. So it looks like no B plus going to this tube up here. That seems to be the main problem that we have. Oh, there's another tube. Oh, did I do that other tube? No, I did everything right. Output tube has voltage. It looks like the audio driving tube, I'm guessing that's what that is, has no B plus. Poor guy. So that's what we really need to explore. You know what I think? I think a schematic is in order here. The schematic, I can already kind of see some of the things I'm bound to do. I'm going to get rid of this capacitor, just get it out of there. Surely the radio can run on this one, not this one. I'm going to check the size of this too, because it looks gigantic to me. Way too big, in fact. Then we'll, with the help of the schematic diagram, we can explore the components that could be responsible for the failure of this tube to get any B+. Hey, don't stick your finger in there, because we still have 200 volts of B+ on there, so I'm going to switch that off. And can you see how slow the voltage is going down up here? Very slowly. So that's another indication that the set doesn't have a problem with leakage of current from the high voltage circuits. Of course, no radio can sustain a significant leakage of current in the high voltage circuits without something happening. Some resistor overheating, some tube, for instance, not working. You can't have a radio running along in that condition. Somebody's going to do something about it. Okay, let's see if I can go find a schematic.